I'm recording now. So let me get to the handout. Just 1 second. Okay, your handout looks something like this. Again, it's like 5 pages. We're going to hit the highlights. Okay, so this says Financial Math Part 1, Overview and Saving for Retirement. There will be another workshop next week over paying off a loan and some strategies. So big disclaimer, big disclaimer. I teach math here. My background is in math. I am not someone who gives advice about finance. I don't tell you what to invest in. I am just showing you how the math works so you have information to use it for your best interest. These were things that I did not know until I started teaching here at Victoria College. I teach a class called Math 1324, which is, it's math for business majors. And I taught that, I guess when I was in graduate school at A&M. And that's when I learned a lot of these things. It was stuff I didn't know, my family didn't know. It would have been a game changer. A lot of things that I'm like, we never felt like we had enough money to do X, Y, or Z. And if we had known some of these things, we could have made maybe different choices. So I want you to have that information so you can see that maybe, there might be little tiny tweaks you could change that make a bigger difference than you think. I guess sort of the feeling we always had growing up was we don't have that much money. What's the point? But if you're strategic about this and you're smart about this, you can, and again, I'm not giving investing advice. That's for somebody else. You go talk to a financial advisor. But if you understand how the math works, there's something called the time value of money. Time is in your favor. So that's what we're really going to focus on. So we're going to give an overview today, and then next time we'll talk about paying off a loan if you choose to come back. So simple interest is exactly what it sounds. The formula is very simple. We're going to save up money. We're going to deposit it into some sort of account. And if the account is set up to collect simple interest or earn simple interest, that means the money you put in, we call that the principal, the amount you deposit, it's called the principal, just grows. And interest is earned on a regular time period. A is the accumulated amount. It's the amount in the account in time T. P is the principal, the amount we put in. R is our interest rate. We're going to have to move the decimal place over 2 places. T is the time in years. But interest is calculated just on the amount you deposit, on the principal only. Okay? And we can figure out what interest earned is. Always think about this. If I'm saving up to buy something and I'm depositing money into an account, there's only 2 ways money can grow in the account. I put money in the account or it earns interest, right? So simple interest, I put the money in, interest is calculated on the amount I put in at the very beginning, and the amount at the end is going to be different because interest was earned, right? So to find interest, it's the amount of the account at the end minus what you put in. So it's very simple. The other 3 formulas are the ones we're really excited about. These are names that are, we've simplified this a little bit. A lot of the formulas, if you open a book, will have a formula like this, but solved for different letters. It might be solved for A versus P or whatever. We've kind of given you the scenario, and you can work with the formula for different letters. So the situation we're calling compound interest looks like this. A equals P times, notice it's a little more complicated, 1 plus R over N to the NT. There's a new letter here, right? We've introduced an N. N will be the number of times interest is compounded per year. So the same thing occurs. We're usually saving up money if we're thinking about this compound formula. I'm making a deposit and I'm letting it grow. So in month 1, I make a $100 deposit. In month 2, there's more, I'm going to do 2 things. I'm going to add maybe another $100, but that money also will grow in the account because interest is earned in month 1. In month 3, I add an additional $100, but interest is earned on the previous amount in the account, which was from month 1 and month 2. So interest is compounded and earns interest on itself. So whatever's in the account, every time interest is calculated, we call that a conversion period. Every time interest is calculated, it's calculated on the amount in the account, whether that was original principal or interest from a previous time period. Does that make sense? Okay, so that's sort of the overview. I've given a lot of information here about how to type this in a calculator. So this is, again, just for reference. You can solve for different letters. Like I said, if you open up some textbooks, they will have double the formulas because they'll solve for P. If you leave it in your calculator, learn how to type it in, you don't have to do that. So the next few pages will show that as well. Okay, and then annuity is very similar to the compound situation in that I put money in on the principal and interest is earned. And then the next time period, interest is earned on the principal and the interest. So interest can earn interest. Okay, so compound interest and annuity both have that in common. There's one big difference. If you're looking at the compound formula, this one up here, we make one deposit. Now keep in mind, again, this is a very brief overview. I have you for an hour. I've been giving you just like the highlights. Okay, you can take an entire finance class and get lots more details. But the biggest thing you need to remember is a compound formula, this formula right here, that's not that interesting, right? It's definitely not as complicated as the one below it. You make one deposit and you let the money grow. This formula here, you make multiple deposits. This formula works with something called an ordinary annuity, and these are going to be certain and simple. Payments are going to be made at the end of the term. The payment period coincides with the interest conversion period, and equal payments are made each term. For the formula, we have to make some assumptions that we're always going to make an equal deposit, that things aren't going to change, interest rate isn't going to change. I'm going to open up Excel after we kind of do an overview of how the formulas work and show you that in Excel you can make those changes and track things. Okay, but for the formula, we have to have things that are constant, they don't change. So here's the letters again, you can read through them. I want to make sure we have time to play in Excel. So here's a lot more information. You might see future value of annuity, this word sinking fund. Okay, all this information here. Let's go ahead and jump to the first example. There's another formula here called amortization. I'm going to hit pause on that one just for a minute. Let's go to this example right here. Here's the scenario. We're going to deposit $250 one time into an account earning 3.21% in annual interest compounded monthly. How much will be in the account in 20 years? So if you read through it and you say, okay, there's a key word in there, the word is compound. So I know it's not simple, right? Throw that one out. But then I have to figure out which of, there were three formulas, I only talked about two other ones, the compound and the annuity. Which formula am I going to use? Well, it says I deposit how much? $250. How many times? Once. So I put the money in the account and I never contribute again, right? The money isn't put in one time and I let it grow. How does the account grow?
Compounding interest.
It earns interest, right? That $250 the first month, because it's this percent annual interest compounded monthly, in the first month, this $250 earns 3.21% interest. Now keep in mind, when we do the percentage like that, we have to adjust the decimal place to do the math, to actually do the calculation. So this 3.21%, remember you move the decimal place over, I did it the wrong one, let me see. Move the decimal place over to this way. I did it backwards. My pencil's not running. Okay, so you get 2.0321 is how we would do the change the value to do the calculation. So month one, you have nothing at the beginning, but at the end of month one, interest is going to be calculated. You're going to have the $250, then 0.0321 times that 250, right? The next month, what happens?
Oh, my sister says she can't hear you.
You can't hear me? Okay, just a second. Okay, people outside, can you all hear me? Did that do it or not? Let's see, audio settings. Can you all hear me? What did she say? Okay, sorry about that. Hopefully it works. Okay. So this is being recorded if you missed the beginning, but big picture is we have one deposit and interest is growing every month. We only make one deposit. So in month one, we put the money in, beginning of, I guess into month zero. And then month one, it earns 3.2% interest. The next month, The 3.2% interest is earned on the $250 and on the interest from the previous month. And it happens over and over and over and over again, right? Okay. So we're going to look at what each variable represents. I like to put them down here. If you have a math teacher who's teaching this, they might do it slightly differently. But I like to label all of my variables. So do you see that P is 250? That's how much I deposited. R, that's that percentage, but I have to move the decimal place over 2 places. N, why is N 12? It's compounded monthly. How many times interest is calculated per year? That's what N represents. And T is the time period. T is 20. So we're going to plug into this formula. And you can type this into a calculator. I brought calculators. Anybody need a calculator? Unless you have one? Okay. So if you have a graphing calculator, there's a way to enter it in nicely. I recommend that if you don't, you kind of follow this order of operations. Calculate the division first. Remember, inside your parentheses is where we start. And we always do multiplication or division first. So do this first. 0.0321 divided by 12, enter. Plus 1, enter. So now we've done everything in here. Then hit the caret key, which it may be a caret like this, or it may be y to the x. Usually open a set of parentheses. 12 times 20, close parentheses. So this is what I would do. I would do 0.0321 divided by 12. I'm going to put equals, but it's really enter. Plus 1, enter, caret, or y to the x, y to the x, and open a set of parentheses, 12 times 20, close parentheses, equals, times 250 equals, and it should give you, what, 4746.66 if you round to 2 decimal places? Let your calculator do all the work. Okay. So now let's look at the next scenario, and then we're going to go to Excel and compare them. So scenario 2, we're going to deposit $200 each month into an account earning 2.4% annual interest compounded monthly. How much is in the account in 20 years? Okay, so notice I jumped right in and said this is the annuity situation because we're making regular deposits. Every month we're putting money in. Does that make sense? So here's the formula. I've replaced the A, P, R, N, and T with the appropriate values. Okay. So then you would type this in, and I've actually typed in all of the steps for you. I'll let you just kind of review that on your own. If you type it in following the steps, at the end of how many years? At the end of 20 years, you would have $61,529.99. Okay? So again, you can take that time and practice that formula. I really want to show you what's happening in Excel. And then we'll go to the retirement question. But I want you to kind of get your feet wet. Is it okay if I go to Excel? This is more of an overview for now. Okay, so go to, there's lots of tabs on the bottom. Let me make it a little bit smaller. If you look, there's tabs that say compound versus annuity, retirement visualization, and so on. Click the one that says compound versus annuity situation. Obviously, I'm putting in very different amounts of money, but I want you to see how you would build a table like this if you wanted to. Can everybody see it? Okay. So first scenario, let me make it a little bit bigger. This is the compound situation. We make a one-time deposit and we let the money grow. Okay, so I built this for you. You can change, you can modify this if you want to do it for your own situation. Okay, why is it not? I need to scroll down a little bit. Oh, okay, I guess the header's, I guess, stuck, frozen. Okay, let me make it a little smaller then. Month 0, there's no interest earned. That's when we start with the initial amount of $250. And I went ahead and put the interest rate here. so it can easily be changed. I'll show you how to change it in a second. So month one, interest is earned. Well, how do you calculate interest? So if you have Excel, you can play with this at home. But for now, I'll just tell you, interest is 3.21% per year, right? But we're doing it monthly. So that's why if you notice, it's the interest rate, the 0.0321 divided by 12 is how much is calculated that time period. Does that make sense? So in month one, you earn 67 cents. Does that make sense? So then your new amount in the account is roughly this. It says approximately because the bank is going to round to 2 decimal places. So there's going to be some adjustment at the end maybe, but if you actually type this in your calculator, it doesn't go exactly 67 cents. Okay, and if you go to month 2, you click up here in the cell, you can see, okay, I'm going to take what's in the account at the end of month 1, multiplied by the interest that was earned that month. So it's the annual rate divided by 12, because only 1 month is being calculated. And that gives you, again, it's not really 67 cents, but we're rounding it to that. Okay, and you can see it starts to change, 68 cents, 69 cents, and so on. And you can see at the end of, was it 20 years? 20 years, scrolling down, 20 years is how many months?
240.
Okay, so you can see I went all the way down to 240. What's the approximate amount in the account?
474.
474.66. Is that what we got when we did the calculation? On our worksheet? It is, right? We type in that formula. Okay, so 2 things we can do. Let's go back to the worksheet, page 1. Oops. How much do we earn in interest? Okay, well, you put $250 in the account, right? You let it grow for 20 years. How did the amount increase?
$224.66.
How did you do that?
Subtracted the total amount at the end of 20 years from the initial deposit.
Okay, the amount at the end minus what you put in, right? And you put in, what's $200, $250? $250. Okay, and so what's that? Tell me again.
$224.66.
Okay, so if we go here, the cool thing with Excel is I can use Excel to give us that value. I can say equals sum. Now look, I'm in the column that says interest earned. Again, this is not an Excel class, but I'm just giving you the very basic formulas. I can highlight all of this all the way up. There are many cells. Close parentheses, equals. That's interest earned. Okay. Now, just so you see, a lot of people don't make this themselves. You really use this a lot. You make a table in Excel if you're paying off a loan, but you can do it the same way. So let me just show you real quick at the top of the file, interest rate. I can change this interest rate. If I put it right here and build the file like this, it'll change the whole table for me. So
if, like, we had our own and somebody gave us an interest rate of 6.3%.
do you work for the mafia?
Change that.
6.3?
Right.
Notice it changes. Okay. So if you want to download this file, you can kind of play with it a little bit. And now keep in mind, interest rates fluctuate, right? We're making an assumption that this is a constant interest rate for the entire 20 years. That's one of the assumptions we're making when we do the formula. But you can tweak it in this, you could change the interest somewhere down here, whatever. You could change it, say, oh, the interest was changed to whatever, and put a number in there instead of referencing that cell. If you want to put in a different deposit, instead of starting with $250, maybe you start with $3,500. So this is a way for you to kind of see, like, if things stay the same way, what can I predict what I might have in the future? And you can pick a conservative interest rate. So this is just showing you how you can use Excel as a tool. Okay, let me put it back to what it was. It was 250, and what else was the other? 0.0321? Okay, now and that's a really good interest rate. Most interest rates now are like 0.1%. They're terrible. Okay, so let's look at the Excel setup if you want to do annuity. Notice the columns are changed. Month interest earned, month and interest earned. But now I have two more columns. This says approximate amount of the account, so does this, but we have to introduce two more things if you're going to build this. This is one way to build it. There's several ways, but I just wanted to build like just from strictly mathematical point of view so you can see what's happening. Okay, so this is the problem we did with the $200 every month. So we make a new deposit of $0. The next month we make $200. See, we add $200 every month. But interest is earned. How is interest earned?
On the total amount.
On the approximate amount in the account. So the reason I had to add an additional column here or two was because I'm putting money in and it's earning interest. So it's growing in two ways. I want to make sure that was reflected. So several ways to do this. You can make it slightly different. But if you scroll this down, you could put your money in the account, make your deposit. The difference is this one, the first situation, compound was one deposit and we didn't touch it. So here, let me scroll all the way to the bottom. This was also 20 years, I believe. Yeah. So you can see, isn't that close to what we had? 61,529.99. Yep. Okay, but how much did we deposit? Equals sum. You can highlight what you deposited and let Excel do the calculation for you. We know we can do 200 times 12 times 20 years. Isn't that what this is? I'll show you. We deposited $200, 12 times a year for 20 years. What's that? 48,000? 100,000?
Sorry, 48,000.
48,000? Right? You go back to Excel, isn't that what if I summed up that column, isn't that what it told me? Okay, I'm gonna go back. Right, that was the sum. Okay, interest earned. I can say, well, how much did I earn in interest? I can sum this. Yeah. Okay, well, let's just check this. If I take the approximate amount in the account and I subtract this, do I get that? So I'm going to say equals, that's where I want this, minus this. The difference between what I deposit and the interest is how much is in the account. Does that make sense? Okay, so this is how the formulas work. Okay, now let's go to the part you really care about. Most of you probably saw that you could save it for retirement. So let's talk about that math. Okay, let's go back to the spreadsheet, the file here. Okay, so suppose we want to retire in 30 years and we want $3,000 per month for 35 years after we retire. So think about that. You're going to retire and then you're going to live off of that money you've saved up for 35 years. And on the last day of that 35th year, you're out of money. So either you hope you die on that last day, or you've been really nice to a family member or somebody who's going to help you pay your bills. Okay, and again, I'm not teaching anything about finance rules and vehicles to put your money. There are some accounts where the retirement accounts, once you hit a certain age and a certain criteria, you have to start pulling money out of them, and that's what I'm talking about. At the end of the 35 years, you have to zero out that account. That doesn't mean you can't put it in something else or do something different with it. But you're going to spend that money exactly in 35 years. Okay, so how much should we deposit monthly into an account earning 6.25% interest, I should say per year, compounded monthly, in order to have enough money for retirement? So I want to make a big disclaimer here. I don't teach anything about finance. I'm not a financial advisor. How many times am I going to say that? Okay, but I'm making, to do this, let's say 40-year return. Average return. Okay, so look, average return of S&P 500 over 40 years is roughly 11.88%. 30 years, if you look at adjustment, 9.89 or 7.31. So 6.25 was just a number that felt sort of safe. The market's going to fluctuate, right? It's going to have really, really good times and really bad times, booms and busts. And we're making an assumption for the sake of the formula, doing the calculation, so we can kind of see how the math works, so you understand why it's important to start now. But the interest rate's going to fluctuate. It's going to go up, it's going to go down. But over the long term, we would say that the average should be reasonable at 6.25 or hopefully higher. Does that make sense? So that's the assumption we're making to show you how this math works. Okay, so the problem has two parts. I need enough money to live on for those 35 years. Okay, so I have to figure out the back end of the problem, how much I'm going to spend when I'm retired. Okay, the front part of the problem is I have to work and save up that money. But I need to know what my target is, how much I need to save. So I have to start with the back end and say, how much am I going to spend the last 35 years? Okay, so we're going to start with the second end. So during the retirement years, this thing froze on me again. During the retirement years, we will have X dollars in the account. We've been saving, working, making regular deposits, okay? On the day you retire, you have a big pot of money. It has X dollars in it. We're going to live off that. So every month, so you retire end of a month. The next month, you have to pull some money out of the account. You're going to pull a payment of how much? $3,000? You're going to pay yourself $3,000 from that account, right? But there's going to be a big pot of money in here. What happens to the rest of the money once you remove that $3,000?
Goes down.
Well, it goes down, but what is the next month? What does the rest of the money do? It earns interest, right? Then the second month you pull out another $3,000. There's still a big pot of money in there. It earns interest. The next month you pull out $3,000. I mean, we're talking $100,000 or more, $200,000. I don't know how much it's going to be. We're going to see. But it's going to be a big pot of money. And so you're pulling off just a little bit. You're pulling off the interest. So the problem I didn't tell you about, Skip, let me go back here. Amortization, the one formula. Let me tell you about it. Amortization is you typically use it where you're going to pay off a loan. But another way of using it is something called present value of an annuity. And that's really the situation we're talking about. There's an expression, he who has the gold makes the rules. So if you want to buy a car, a house, or whatever, you don't have enough money to buy it in cash, you should, you go to a bank or somebody, credit agency or somebody, and you say, I would like to buy this, and they say, sure. But for the privilege of using my money, you get to pay me some interest. Okay, and then next week, if you want to come back, we'll talk about what that looks like, paying off a loan. But interest is going to come right off the top. They're going to get their interest first, and then the rest is going to go toward the principal. So the same thing happens if you're saving up for retirement. You have this giant pot of money, and you're paying $3,000 for your monthly expenses, but it's still earning interest. You're like paying yourself almost like an interest payment. Okay, so we're going to use the amortization formula because we're going to pay ourselves a monthly payment, like the interest off the top. It's really the present value of an annuity. So here's the formula. Again, if you take a math class that deals with this or a finance class, you'll get more details. I just wanted to go through what is happening. So you plug this in. Here's the calculator steps. You can practice them yourself. But what's interesting about this is if you want to spend $3,000 every month for 35 years, you're going to spend $3,000. When I say spend, you have to pull it from the account. You have to spend it. $3,000 every month. How many months are there a year? 12. For how many years?
35.
35 years. What is that? 3,000 times 12 times 35.
126. Oh no, I'm sorry.
How many zeros? Just count the zeros for me.
4 zeros.
4 zeros.
And then 126.
Okay, so look at this. Let me write it a little bit better. 4 zeros. 1, 2, 3, 4. How much money will you spend in retirement? Just from this account. Will you pull out of the account, I guess?
$1 million.
$1.26 million. Okay. Now, when you do the calculator steps, plug in this formula. This is how much you need on the first day of retirement. Significantly less?
So by the day you retire, if in those 35 years you want to be able to spend that amount, that has to be there?
Okay, so yeah, if you're gonna spend this in that 35 years after you retire, $1.26 million, on the day you retire, this much has to be in your account. Less than half. This should be mind-blowing.
Yeah.
It was to me. Remember, I came from a family that didn't save up for retirement. We could barely make ends meet sometimes. They didn't feel like there was a lot of money. But I'm like, okay, why? I need less than half of it. Why do I need so little? I mean, this is still a lot of money. You'll see what's going to happen in the working years. But it's going to more than double. Why? What's happening to that pot of money? It's earning interest every time. Okay, so here's the really, really mind-blowing part. Ready? You thought that was crazy. I remember this was crazy to me when I first taught this. Okay, that's how much we're going to need the day we retire. How much do we need to deposit every month while we're working to get that amount? And again, we're making an assumption it's the same from the beginning. But then we're going to play in Excel and show what happens if you change it. Okay, so working years. It's the annuity situation, right? I'm making regular monthly deposits. So I need to have this amount at the end. Now I'm solving for P. And you can type this in your calculator. You're going to see that you need to deposit $484.86 every month for 30 years in order to have 1.26 million when you retire. Spend that much of your retirement years. This is a car payment. Right? I mean, so when you think about that, you're like, a lot of people, my family felt like retirement savings was out of reach. Now, I do understand you may have children, you may have car payments, you may have other bills, house payments. It may be hard to do one more thing. So that's why we're going to go to Excel in a minute and practice. But there's something called the time value of money. That first $484.46, let's assume first in, last out. Let's say that $484.86 was in the account for 65 years. Right? It's the first in, like over your 30 years of working, and maybe it's the last one out. So some of that money's in there a long, long, long time. How much do we actually deposit while we're working? Well, we deposited $484.86. How many times a year? 12 for how many years?
35?
30. This was 30.
Oh, 30, sorry.
Yeah. Tell me when you got it.
174,549
549.
and 60 cents.
549.6. Okay. 549.60. Okay. I want you to carefully look at this number. I write it down. I'm going to scroll to the top. And look at this number. Crazy, right? Okay. So are you getting the point that the longer it's in there, the better, right? And obviously there's going to be, you might lose some money. There's a risk over the long term, right? We're saying you're riding this out for 65 years. By the time you put the first deposit in and you take your last deposit, a lot of that money's been in there a long time. There's going to be ups and downs. Okay. And you want to make sure that you talk to a financial advisor who can advise you about what kind of risk you're willing to take, things like that. But if that money sits there and just grows, significant difference. Got it? Okay. So what about this? We deposit $50 a month into an account earning 6.25% annual interest compounded monthly starting at age 25. Okay? We do this monthly for 10 years. Then you run out of money, right? Maybe you lose your job or you buy a bigger house or, something happens in your life and you can't continue to contribute. Okay? You let the money grow. You check the balance when you're 70. Do you see what's happening? We put the money in for a little period of time. We're contributing for 10 years. And then we let it grow for 35 more years. And don't touch it. Okay? So the first part of the problem is the annuity. I'm making a regular monthly deposit. Okay, so again, You can look at the formula. We would plug in like this. The first 10 years, this is the first 10 years, right? This much is in the account. I am now 35 years old, right? I think I said I was 25, and I'm doing this till I'm 35. And then something happens, you have more expenses, whatever, fill in the blank. You say, I'm not going to touch that $8,300. I'm going to leave it in there, but I cannot afford to contribute any more to this for whatever reason. So the money just sits there and it grows. The formula is a little less exciting, but it grows nonetheless. At the end of 35 years, you'll have $73,000. How much did you deposit? Well, you deposited, how much? 50 a month times 12 months. Don't forget the months, 12 months times
10 years.
10 years. Okay, what is that?
6,000.
You deposited $6,000. How much do you have in the account?
73,000.
It just grew. I mean, like if you had taken the money out, done something else with it, you could have. It doesn't, I mean, this still grows a whole lot slower than you're regularly contributing, but it's something, right? Okay, let's change it. What if you just couldn't afford to? I mean, a lot of expenses, you barely making ends meet. Finally, you get to the point where your kids are moved out of the house and you've paid off some bills and you're going to start saving it for retirement. Now you're 50. So how much will we need to deposit to get that same amount as that person who started when they were 25? Time value of money, right? The account was in there when they were 25 to 70, I think. Here, you've got to go for 20 years, less time period. So you plug it in. Here's the formula. This person has to deposit $154.66 every month in order to have the same amount of money when they're 70. How much did they deposit? 154.66. How many times a year?
Well,
For how many years? How old were they? 50? So 20 years? 20 years, what's this?
$37,118.40.
Okay, look at this number. And look at this number. Okay. You start to see how this works? Okay, now we're going to play in Excel. This is the part that you can really kind of see lots of different scenarios. That person can get there, the person who waits until they're 50 can get there, they just have to contribute more every month. This person only put in money, for 10 years? But because it was 10 years at the beginning, made huge difference. Okay, let's go back to Excel. So if you notice, there's several tabs at the bottom that say retirement visualization, and then some retirement scenarios, more retirement scenarios. So let's go to retirement visualization. That's the first example. When we said we were going to deposit $484.86 per month into an account, earning 6.25% interest compounded monthly. We're going to do that for 30 years. And then after that, we're going to live off of that for 35 years. So this is we talked about the working years and the retirement years. This retirement years, you needed $1.26 million. Okay, so this is the Excel spreadsheet for this. I just said, let's say you're 25 when you do this. When I ask my students, they usually say by the time they get out of college and kind of get a little bit of money set up, they might be 25. So if you're 25 and you do this, you can see that month interest earned, account value before we make the next deposit. We add a new deposit. How much is in the account? So you can kind of scroll through this. And you can see how the money's growing. If you notice, look at the beginning. Look at the first interest rate. Pretty low because there's not much money in there. $7.62, right, for, what is that, month 4? Well, if I could scroll to when I'm 41, $822.90 is how much I'm earning in interest. That's free money. But it's because there's significantly more money in the account than there was at the beginning. Does that make sense? Okay. So you can kind of scroll through this. I'm going to work until I'm 55. So I'm at 52, 53, 55. This number is a little different than what we had, I think, isn't it? 511, what was our number?
$6.67 was at the end.
Yeah, so it's off a little bit because of rounding, but it's roughly the same thing. Yeah, 511,006.67. Okay. And then the retirement years, I just started it again. Okay, the day of retirement, I have this much money in there, and then you make a withdrawal, right? You're paying yourself. So this situation is the amortization. Notice all the headers have changed. We're subtracting this time instead of adding. We're pulling money out of the account, $3,000 each time. Okay, does that make sense? And you see that this is how much I had at the beginning, and it's going to zero out when I am, how old? So I'm going to live until I am 90. And it's not quite 1.26, but it's pretty close. Off a little bit because of the rounding.
That's pulling out 3,000 every month.
Yep. Yep. I don't have 3,000 the last month, right? I'm a little short. That's why this stopped. Okay, does that make sense? Okay, so big picture, do we understand why this is important? Okay, now let's go to the next one. Some retirement scenarios. Okay. So this is the next situation I just told you, comparing the person who deposited money for 10 years and then stopped. Okay, so that's this, and then the person who started when they were, wait a minute. Do I have it over here? Okay, now this is the first scenario. So you deposit $50 a month, do it for 10 years. Okay, so if you scroll to the top, I'm 25, I put in $50, and I let it grow. Do it monthly for 10 years. So I'm going to be 35. I missed it. Yeah, so look, finally found 35. $50. Now I put nothing in there, but this money's still growing. Not as quickly, right, but it's still growing. Why is it growing? I'm earning interest, okay? And so you keep depositing, and you can see, scroll all the way to the bottom, that when I get to 70, I put in $6,000, I'm gonna have the $73,000, and I kept it going. Now here's a scenario. I didn't put this in our paper. Notice this one says do it monthly for 10 years. What if you do it for 20 years? Look at the difference. Wait a minute. Oh, this is the one who started at age 50. I'm sorry. This is the one who started at age 50. Notice the amount is the same, or pretty close. It's off a little bit. But we paid $37,000 instead of $6,000. So here's the Excel kind of showing you that. Okay, now here's some ones, what if we change it? This is what I thought I did. So what if I deposit $50 for 10 years? I just made up some scenarios. $50 for 10 years. That's the first part of the scenario, right? 8306, that's what we had earlier. Okay, then I say, maybe I'm doing a little better. Instead of saying I can't afford to contribute at all, maybe I can do $100 now. How much do I have at age 70? So here's my age, watch this column. Probably have it highlighted. At age 70, getting there. Okay, I put in $48,000. Because you start young, right? As soon as you can. I tell my students, go and get an account, put in $20 a month. When I first started working here, I was broke, paying off loans and trying to, it was crazy. And I didn't know this stuff. I did not grow up in a family where we had this information. It would have made a big difference. And keep in mind, there's lots of rules depending on what kind of account, how much you can pull out and different things. Talk to somebody who knows. But I said, okay, I can afford, it was embarrassing. I was like, I'm so embarrassed. I can afford $20 a month. Really couldn't afford that. I was eating ramen noodles. But I thought, I'm going to set aside $20 a month because I'm still trying to pay off a lot of things. And she said, okay. She didn't judge me. I felt really embarrassed, like it's not much. And then a couple of years later, I'm like, what if we make it $40 a month? And she's like, okay. And we changed it to $40. And then next year I said, what about $50? Right, until I was, because I understood now after I taught this class, whoa, the time makes a bigger difference. So you can see, I've just given you lots of scenarios to play with. You can click, there's even one here where if you notice this one starts at age 22 on this side. Start at age 22 and you put in $10 or whatever versus someone who over here. So I just kind of build in some things where you can play with it. Someone puts in 50 at age 25. You can say, what happens if I put in, $2,000 from the beginning? How much does it change? If I start off with one deposit of $2,000 and then it's 50 from there on. So the cool thing about Excel is you can change it for a one-time different scenario. For the formula, I can't do a calculator. I put in $2,000 here one time and the rest it's 50. I have to do the formula with the same constant number. For Excel, though, I can make one change and see what happens. And then I can make a different change down here and say, okay, what if this month I can put in $20? Okay, what changes to the whole number? You can kind of play and say, okay, well, maybe I got a raise at work or a bonus or something. And I'm going to put an extra, $1,500 here instead of the $50. And you can kind of see. Remember, this just gives you an idea because the interest rates are fluctuating. But at least can kind of show you how the money works, how interest works. This is very powerful because interest earns interest. That's what makes this so powerful. So any questions? I know that's a lot of information really quickly, but we kind of wanted to give you, this is information I did not have until I started working here. My parents would have really greatly benefited from this information. Any questions? Anybody outside have questions?
How can we see what the interest rate is right now?
You can just do a general, if you want a bank interest rate, it's going to be terrible. You deposit in your bank, it's usually like today's interest rates. Let's see. This is for paying a loan. Let's say savings account interest rate. Savings account. You can Google it.
Like an account like S&P online or
You can. You can. Where's the best? Okay. Here we go, right here. Look, not real good. 0.25%. Keep in mind, you have to move the decimal place over 2 places. Okay?
0.25%. Oh my God.
Yes. So you probably want to go and do some sort of account. Some people invest in the S&P 500. It's like a mix of things. A lot of people do their own research. You can go to a financial advisor and they can recommend some things. Lots of you can do stocks or bonds or money market accounts, lots of things. Sometimes a bond might be really high. If you get the bond and let it go for a while, it might be much higher than what's happening in the country if something happens with, interest rates or recession happens or inflation kicks in. So the best thing is to just start doing your homework and just be aware that this is possible. You always want to make sure you keep your risk, what risk you're willing to take.
With that interest rate, if I deposited $10 a month, starting when I turned 23 right now, I would have $38,000 when I'm 70 and have paid $37,000.
Exactly. So you don't want to do it in a bank savings account, but you want to do it with, you want to talk to somebody who has this information. I'm not an expert. I just want to show you how the math works.
Right.
That use the math in your favor. Use the interest in your favor. And here's what you do. You save it for retirement, but maybe you're not ready for that right now. You put a little bit in the retirement account. Maybe you get another account and you save up to pay off your car, to buy your car in cash instead of financing it or whatever. But you just be smart about it and say, and I understand there's limited funds. You have to pick something, right? You're going to have a car payment or a house payment, or you got to make sure you pay your bills, whatever. But you want to make sure that you're smart about it, at least know what options there are and how much, what you can do with your money. Okay, any questions? Okay, if you're off-site, please put your name and your V number in the chat along with your math and science teacher's name.